Hello. Hello. All right. Good morning, you people, and all those people that decided to stop off and get me donuts for the whole class, because that's the only reason why. Listen. Life. Okay, here's a life hack right now. If you know you're going to be late to a meeting or some office type of thing, you're already going to be late. Grab donuts or something for the people in the office. So they say, oh, I'm sorry I was late. I was picking up this for everyone. They'll excuse your lateness and you'll be good. We wouldn't have any problem, right? They'll be like, oh, that's all right. Thank you. I appreciate that. Okay, so now it's no longer a negative that you're late. You're like, okay, hey, is she going to be late today? I don't know, but I was looking forward to those donuts, man. So that's life hack 101 right there. So anyway, all right, so we're going to finish up what we're doing here, I think. So find the derivative function at a number. So the derivative is just the slope, right? At a point. So we're doing this at a certain point. So it's the instantaneous. So it is find the slope of the function at a specific point. All these are going to be curves. Linear, let's say linear. So if you look at linear, it's any equation y equals mx plus b. What's the slope? M. Because that's always the slope of a linear. Linear stands for line, right? So it is going to always be the same. That's why it's always the m in front of the x. But we're going to be dealing with other functions that are not linear, which are not just x to the first. They're going to be x squared, x cubed, root x, e to the x, all these other things which are not going to be just a straight line. And that's why we actually have to find the derivative, okay, to get the slope at that point. It's not possible to say that it's going to be across the whole thing. That would be the average slope or the secant line. But what we're talking about is just the slope at a singular point, which is the tangent line. A tangent line touches only at one point. Find the derivative. Okay, so if we did this like we did earlier, we would go, let's see, limit as x approaches 2, right? Yeah. And it's going to be f of x, which is 2x squared minus 3x minus 2. And then it's minus, all right, so f of 2, let me see, that's going to give me 4, 8, right? Minus 6, which is 2, minus 2. Let's try this again.
4 times 2.
Okay, so 4 times 2 is 8, right?
Yeah, 8 minus negative 6.
8 minus 6.
2.
2 minus 2.
0.
Hey, look, that's easy. And that's going to become x minus 2, right? Okay, good. So now, same thing that we did on the warm-up. That warm-up problem was there to try and wake up the brain, do all kinds of creative math. So I know I can't plug in 2 right away, right? I cannot plug in 2. So I know there's got to be a factor of x minus 2, shouldn't there? There's going to be an x minus 2 somewhere. So let's go ahead and do distribution on this. So what it's going to be. So when I factor the top, it's going to give me, let me see, 2x squared, factors of negative 4 that add up to be negative 3, so that's going to be negative 4 positive 1. Yeah. So negative 4x positive 1x minus 2. Did I do that too quick, or do you guys want me to go back over that? Are we good? Okay, because I never use that little x method thing, so my method's a little bit different. So you can get the factoring a trinomial. Okay, so factor by grouping. I can take out a 2x. I'm left with x minus 2. I'm going to take out a positive 1 plus 1, because I already have the x minus 2 like I need. X minus 2, and I'm left with a quantity of x minus 2 times 2x plus 1. There we go. So now I can do my x minus 2, 2x plus 1 over x minus 2. And we're taking the limit as x approaches 2, because right here, what's going to happen? Those cancel out. And so since those cancel out right there, I could plug in a 2. 2 times 2?
2, 4,
Plus 1.
5.
Yeah, you were checking me this morning, right? You notice my coffee is still mostly full, so you're like, hey, I'm going to try and slip one by him. Okay, so yes, we get 5 as my slope. So the derivative of that means that the slope at 2 is positive 5. So now think of it in rates and changes. So if this was the velocity, which is the derivative of the position, what would that mean?
It would be moving 5 units per time.
Whatever my velocity would be 5, right? So I'd have a positive velocity, right? A positive velocity of 5 units per whatever it is, right? Okay, so good. All right, so let's try.
Is there negative velocity?
Yes, there is. Negative velocity would go where?
The opposite direction you want.
Opposite direction. Very good. A negative velocity goes the opposite direction. So think about here. So if I'm going here to Douche Bros over there, which they don't have a walk-up window no more, I'm going from here to Douche Bros and I'm walking, let's say 6 miles per hour. So from my starting position, I have a positive velocity here. Okay? I have positive velocity. So I'm going that way. So I'm going in that direction positively, right? From the starting position, because we're starting from position and then the derivative is my velocity. So my rate of change is going to be 6 miles per hour, okay? And then on the way back, I'd be walking 6 miles per hour also, but that would be a negative velocity because I would be coming back off of my position. I'd take it away from my position. So you want to, it's super neat. So think of it like this. So if I'm doing it, I would go like this as a graph. It's kind of like a sine wave. So I'll show you like this. Here's my positive velocity. Here's my negative velocity. My positive velocity takes me to Douche Bros right here. And then my negative velocity, because this is all over time, my negative velocity would cancel out all the positive velocity that I went. So that means even though the time keeps going, my position puts me back at 0. Yeah, we're gonna actually do a whole lot more of this later on. So when we actually start talking into first, second, third, and we don't do fourth. Fourth, yeah, 1, 2, 3, 4, 4. Third, we don't go into 4. There is a fourth, but yeah, we don't do that, which actually has to do with friction. But anyway, yeah, never be a third derivative. Do not be a third derivative. It's a math joke. It's a jerk. It's an instantaneous pull. It's jerk. It's called a jerk. Anyway, so far we have given 3 interpretations of a derivative: geometric, rate of change, and physical. Okay. Find the derivative of this at this, and then find equation of the tangent line to the graph at that point. Okay, so now let's do the same thing. So I'm doing the limit as x approaches 8 of, let's start off with f of x, which is going to be radical to x minus, okay, plug that in, 16, square root of 16 is going to give me 4 over x minus 8. All right, so again, what do we say? There is a problem here. Because if you got a problem, I'll solve it.
We say f that.
We need an exponent on top.
Yes, I do, right? I need more exponents on top, right? To try and fix this. to cancel out, I need more exponents. So can anyone recall what is that special thing I said that you got to do?
Multiply by the reciprocal.
Not reciprocal.
Or the opposite of what's minus 1.
Square root of
What is that?
Oh,
2x plus 4, right? What's it called?
Shoot, it's
Starts with C, engine adjective.
Conjugate.
Conjugate. Yes, there we go. All right, so the conjugate. We're multiplied by the conjugate. Conjugate, conjugate, conjugate. Say conjugate.
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 Can I get a conjugate?
Can I get a conjugate?
Thank you. All right, so
Nice.
So let's go ahead and do some distribution. So,
I am distribution.
Oh, yeah.
all right, so go ahead, distribute all that crap. So you're going to end up with a 2x minus 16 over quantity of x minus 8. Oh, crap. So if you need to go ahead and distribute the whole thing out so you can see what happens, the conjugate always gets rid of my middle term. That's the reason why I use it. So that means the middle term, which is going to be the square root of x, or square root of 2x, is going to go away. I'm glad that goes away. So now, that's left, and I still have my square root of 2x plus 4. So I can factor out a 2 again, right? And I'm left with x minus 8 over x minus 8, and I have square root of 2x plus 4. And those things go away. So now we're taking the limit as x approaches 8. So I'm going to end up with 2 over 2 times 8 is 16. 4 plus 4 is 8. 2 over 8 is 1/4. So my slope is 1/4, right? Say yes.
Yes.
So the slope is 1/4. The derivative at a point is the slope. So it asks for the equation of the tangent line. Okay, so now do I have the slope? Say yes.
Yes.
We have the slope. Do I have a point?
Yes. 8/4.
8/4. And if I didn't have the whole point, what would I do to get the 4? Plug it into the function, right? Plug it into the function. If I know x is 8, plug it in here, and so that my output, 2 times 8 is 16, square root of 16 is 4. F of 8 is 4. That's where I get that. So a lot of times you're not going to be given the y value. You'll only be given the x value. Okay, so I'm going to next page this one. Oh crap. Tools, insert, page, after. All right. So we have y minus 4 equals 1/4 quantity x minus 8. Point slope form. So let's see, you can get y minus 4 equals 1/4 x minus 2, and then y equals 1/4 x plus 2. Questions? We good? Are we okay? Okay.
Yeah.
I think that one's it. Approximate derivative function divided by table. Okay, right here, continuous over the interval. Find the derivative at 2. What's one way I could do it? So to approximate the derivative at 2,
Point slope. You can find
I could just
slope.
use a slope, right? I keep saying all the time that derivative is just a slope. So if it's at 2, what would I do? Would I use 2 and 3, 1 and 2? How would I do it to approximate it for 2?
Use 2 and then 33.
Is 2 right there in the middle?
Average? Or-
Yeah, because we're just trying to find a slope. Approximate it.
oh.
So if I'm approximating, if my interval is pretty consistent here, on this one, I can approximate it, right? I can take this one and this one, and that would give me the slope in between both of these, which should be somewhere about the same as what it would be right at 2.
That's cool, that's cool.
Slope seems it should be 15. Okay, that's a good approximation, yes.
Is that the slope formula or what?
Yeah. This is y2 minus y1 over x2 minus x1.
Let's say you got
Yeah.
3 minus 4.
Very good. Is that super? That's super easy. All right. Okay. Don't forget, like, share, and subscribe. Okay.
What if I don't